Vehicles of the future will know exactly where they are and the best way to reach their destination. Several requirements must be fulfilled to make this possible. One of these is the eHorizon project of the international automotive supplier Continental.
The electronic horizon is the base for the variety of new and enhanced functions. If the vehicle knows the environment, the road ahead, it can travel safer, more efficient, with higher comfort. It also supports automated driving based on those capabilities.
The information that eHorizon transmits to vehicle and driver goes far beyond what navigation systems have been capable of up to now. In this case, the vehicle connects to the cloud and checks for any updated information about its required route.
We are not only downloading traffic data, we are here downloading static map data. Very important to validate the map in the cloud. For example, do we have new roundabouts, new traffic signs or other information in the map? And once we recognize we have new data, then we are downloading those map tiles into the vehicle. That leads us to the situation that the map in the vehicle is always up to date and highly accurate.
But that is just the beginning. eHorizon also includes the most up-to-date traffic information, keeping both drivers and vehicle systems in the loop.
The in-vehicle sensors collect the data, we store the data, evaluate in the vehicle, and the most important data we send into the cloud. In the cloud, we collect the data from different vehicles, evaluate those data, and send them back to the vehicles which need them.
An example. This car is travelling along the same route as our test vehicle. It comes across some roadworks, protected by a speed limit. The sensor technology in the car detects the speed limit, displays it on the monitors, and processes it internally. The information about the location and the nature of the speed limit is then immediately sent to the eHorizon Nerve Center in the cloud. From there, the data is sent to our test vehicle, which is also travelling on this route. As it approaches the roadworks, the vehicle displays the speed limit well in advance. The driver and the vehicle now have the most up-to-date information.
Vehicle sensors can provide lots of different information. For example, speed limit, average speed, closed lanes, etc., etc. We are sending all that information to the cloud. Important is that the cloud collects information from different vehicles, validates that information, and based on that validation decides what information is important and what's not, and then sends that information to those vehicles that need it.
This principle means the electronic horizon will keep all vehicles equipped with this technology up to date.
The more vehicles take part in the eHorizon, the larger the information density, the better the information quality. That makes the eHorizon more reliable and more up-to-date.
A future with fully automated driving would not even be conceivable without this information from eHorizon. This test vehicle from Continental can already automatically accelerate and brake without the driver having to do anything. eHorizon provides it with all the data it needs about speed limits and curve geometries. In the future, this vehicle will also be able to react to the latest reports. This means that as soon as eHorizon informs the vehicle system of a new speed limit, it will automatically adjust its speed. Another of Continental's test vehicles has a 48-volt hybrid system. In urban traffic, it is already possible to make considerable fuel savings by using targeted measures such as coasting and energy recuperation. This effect can be increased even further. Additional up-to-date information about traffic flows and traffic light phases that this vehicle receives from eHorizon will enable it to move through the traffic more efficiently and economically.
The electronic horizon creates lots of new opportunities for the vehicle of the future. Above all, it is an important building block of the automated driving.